Now let's do this question. You can see here, the question is today challenge, and then it's medium level question. Now let's, you can see linked list in binary tree. So given binary tree, look and the linked list with head as the first node, right? First node, and return true if all elements in the linked list starting from the head corresponding to somewhere the path connect in the binary tree, otherwise return false. So it means if we couldn't find the path in the linked list, okay, we just return false. Otherwise, if we find the matching path in the tree and the linked list, okay, we just return true. Now here, in this context, downward path means a path that start at some node and go downward, right? Now let's see, this our example, and you can see the handle is 42A. Now you can see in the diagram, we know, we find the linked list in the tree, right? 42A, and then here that's why here return 2. And from here, you also return 2. So 1, 4, 2, 6. And then we need to find the matching path in the loop, right? Any path is fine. We just find all the number, all the elements in a tree in a path, right? So to return true. Now here, return 4. Now, how do we find this path in our tree? So I think we need to check the first node, first root, right? If this root equal to the head node, okay, which means, so actually we had 2 pointer, one pointer at the tree, the second pointer in the linked list, right? The head node. Now we need to check the both value are same or not. No, okay. So if we couldn't find the node in the head node in our tree, so which means we need to go to left or right to find the matching value. So now we first we need to go to left, right? Go to left first, and then we find, okay, we find a 4. 4 is matching the head node. Oh, okay, which means we need to move our pointer. We need to move our pointer to second. The head node need to move to second, right? And then here is tree, right? We know tree have two options: go left children or right children, right? So actually here we couldn't find the children, so we only one path. We can go to right, go to right children. Now here we know the both point already point to the second node, right? Now we need to check the value, the two value are same or not. So definitely they are same, right? 2 equal to 2. Okay, which means we need to move our pointer. In English, we need to pointer to last node. If last node also matching, which means we find the path in the tree. Now here same thing, right? Here same thing. We have two options: go left or go right. So now we go to left first. So we find out, okay, this one is 1. Okay, 1 is not equal to A, right? Okay, now we need to, and then we try to go right, but right is no, right? So which it means the path is not correct. So we need to go back. We need to go back to the original, and the point, the list node, the point needs back to the head node, right? Need to back head node. We need to find another node 4, the node with value 4, right? So now here we keep going down. Okay, it's 2, right? 2 not equal to 4. Okay, we just skip it. We need to keep going down. It's 4. Okay, 4 is not equal to the head node. Okay, we just skip it. And we already reached the end. Now we need to go to the right path. We need to start from here. And we found out, okay, the 4 is equal to the handle. Okay, which means we need to go, the handle needs to go to next node. And here, do the same thing. We just repeat the process, right? So now here also have two paths, right? Go left and then go right, but actually, I've obviously here not no any node here, right? So 4 doesn't have right children, so we just only consider left children. Now here we'll go to here. Okay, we'll find out it's 2. 2 equal to 2. Okay, now we're moving the node to next. Now here point to the A. Now here we also have two paths, right? Go left or go right. So we can see 6. Okay, 6 is not equal to A. So we just say it's dead end. So we cannot keep going down, right? And now we try to go right children. Okay, we find this one's A. A equal to A. Okay, we find all the elements in the tree. So we say we need to return true, right? Because it's our path. We find the matching path in the tree. So we just return true. So now let's start this one. First step, we need to head equal to no, which return true. So we don't need to find the path in a tree, right? And then if root equal to no, we need to return the 4. So you can see the handle is we need to read this statement first, right? Before this one. So if this one doesn't get executed, and then this one get executed, which means we already find all the paths. We already find all the node in the tree, but still not find the matching path from the head, right? It's mean they doesn't have a matching path in the tree, so we just return 4. So yeah. So now here, if handle 1 equal to do that value, we need to do one thing. Okay, we need to call the DFI function, and then we need to pass head and the root. If here return a true, which means we find the path. So here we need to return true. Okay, if this statement never get executed, which means we didn't find the matching node in both, right? So now here we need to go to the left children and the right children until we find the matching node. And go right and go left and go right? So we just keep going down. We have two options, left and right. If here get executed, which means we couldn't find the node in the both tree. Now here we need to complete the df function. You need to return type boolean, and then we need to list node is head and tree node. Now here we do the same thing, we just copy paste. If the handle reach the end, which means we find the matching path in both, right? In both tree and then this node. And then if root dot value not equal to the head dot value, so we need to return 4. So we don't need to keep going down because already have one value is not correct, right? We have to return 4. And here we need to call the DFS. If this one never get executed, which means we find a matching node in both, right? So now we need to move our node into next and look at left. But we don't know the left children match the next head node over right? We don't know which one. So we need to check in both paths. Now let's run it. Oh, okay. It's return it. Oh, here I forgot the closing bracket. Oh, I provide the not correct function name. Now you can see it passed on the test case. Now let's analyze the time complexity is the n times m, right? Now let's see it's space. Okay, n plus m. So you can see the time complexity is b of n times m. N is the root. M is the handle, right? So oh no, sorry. The n sorry the n is the b of the time complexity is b of n, where n is the number node in the tree, and the m is the sub-children, right? It's the sub-children because we need to find the matching node first, and then we can keep going down to find the path. So the m is the path, the number node in the path. Yeah, thank you for watching this video.